Here we go, folks. We're now looking at the central limit theorem, example number 2. All right, so the narrative says we have a large population of overweight adults. It says the mean cholesterol is 220, all right? And it also says that the standard deviation is 16.3, all right? Now, that's a variable, X, cholesterol. Oh no, it doesn't say anything about being normally distributed. Oh no. What are we going to do? But here's where it's really important to keep reading. It says we have a sample of 64 adults. A sample. And then it goes on to say, find the probability that the mean of what? The mean of that sample, the mean of a sample, that's called X bar. Look at this. We're jumping over to the X bar, the distribution of sample means. That's extremely important to notice that. All right? So keep in mind that they sampled 64 adults. Find the probability that the mean of a sample. So here we go. We're jumping over to X bar, and our probability involves the mean of a sample. All right? And it says between 223 and 225. So 223 is less than X, which in turn is less than 225. There you go. That's how you write that out. Between. All right? Mean of a sample. That's so important. We're jumping from X to X bar, all right? And the point would be that we are about to apply the central limit theorem. So I'll put up the generic theorem up here as we filled in when we did example 1. Watch these in order, guys. It really helps. But anyway, the mean for this distribution is the same as the mean of the original. So that'll be 220. But the standard deviation, there's a new standard deviation in town, all right? And you always get it by taking the standard deviation of the original population and dividing it by n. And I want to remind you, n is always the size of your sample. If you go back and read the question, it said that they sampled 64 adults, all right? So we're basically taking 16.3 divided by, and the square root of 64 is 8. So that would be 2.0375. That's our new standard deviation that we're going to use throughout the rest of the question. And again, we made that jump over there to X bar when the question mentioned the mean of a sample. Find the probability related to the mean of a sample. All right, so here we go. Now, why is that weird man drawing a bell curve? It never said normally distributed in the question, did it? You're right, good question. But the central limit theorem says that if you sample at least 30 and you're doing the probability related to the mean of a sample, so that's part of the theorem. This is normally distributed. That is part of what the theorem is telling us. So that's our justification for going over here and drawing this beautiful cone head looking bell curve, okay? So, we're ready to roll. We've got a normal distribution. We're talking about the region between 223 and 225, which are both above the mean, by the way. So this is beginning to resemble assignment number 17, where we had a bell curve, a normally distributed variable, X bar, all right? And then if you recall, we changed that into Z by standardizing. So at this point in time, we would draw the corresponding standard normal, bell curve 0 in the middle. We've got a couple of values that are above the mean. I'm hoping at this point everybody's like, oh, this is so assignment 17. We've already done this kind of thing. And so we would standardize both of these. Remember our good friend, Z equals X minus mu over sigma. Let me write that down over here. That's our friend. Now, let's keep in mind, we're using this information because our variable is X bar. So when we standardize the 223, that would be 223 minus 220 over 2.0375. Boom, drop that one in there. All right, and that's going to be basically 1.47. 1.47 is the standardized value for the 223. Do the same thing for 225. 225 minus 220 all over 2.0375. I wish I could stretch this out more on the board, guys, but see, if I keep going out here, you won't be able to see it. So that's the problem with framing this up. I'm trying to keep it closer, but that kind of confines my board space a little bit here. But that standardizes to 2.45, all right? And then, you know, I went ahead and did some of the work on this to keep it moving here. It would be table time now, wouldn't it? So the idea would be we would go to the Z table and we would look up these two Z scores. 2.45 it turns out, which I want to remind you would get you from here to the middle. And I did this ahead of time to keep things moving. That generates a middle sliver of 0.4929. All right. And then the 1.47, when you look it up, generates a middle sliver of, I didn't do a very good job of this, board space, I'm really sorry. That's 0.4292 sliver. And I hope this picture, and now everybody's hopefully going, this is so assignment 16. And it is. So you would subtract those two to get this probability. So 0.4929 minus 0.4292 ends up being 0.0637. Final answer. All right. So I hope that made sense. We'll keep practicing these. The key element, again, was to recognize on this question that when they mentioned the probability related to the mean of a sample, that it was appropriate to apply the central limit theorem and jump over, all right, and apply the theorem. So we jumped on that one because the mean of a sample. We had X, but the mean of a sample is 12. Ready to jump over to X bar. Well, that guy's got some ups, doesn't he?